Imagine you're staring at a jumble of data, sales numbers, photos of cats, or sensor readings from your smart device. You wonder, can a machine actually learn from this mess? Aurélien Géron takes us straight into the command line of his laptop as he runs a program that predicts house prices using nothing but Python and a clever library called Scikit-Learn. But how does this magic happen? Let's crack open the toolkit and find out. Before jumping into neural nets and deep learning, the book grounds us in a familiar place: classical machine learning. It's the foundation, your stepping stone. Aurélien walks us through a case study tracking a housing prices prediction model from raw data gathering in Boston to cleaning, training, and final validation. No magic, just clear steps using Scikit-Learn. The project feels alive, real, and doable, even if you're not a math whiz. Think of these classical algorithms like a seasoned detective solving a puzzle. Linear regression draws a simple line through scatter plots like a tightrope. Decision trees behave like an interrogation flowchart, asking yes-no questions until they pinpoint an answer. The complex made intuitive through analogy. By the end, we see how these tools, some decades old, power things we use daily: recommendation systems, fraud detectors, even spam filters. It's a humbling reminder: you don't need to build the deepest net to build something useful and impactful. Now the book pulls you into the deep end: neural networks. They're the sexy headline of AI, but how does Aurélien make these complex architectures approachable and even fun? Aurélien demystifies TensorFlow by guiding you step by step to build your first neural net. From defining layers to feeding inputs, it feels less like black magic and more like assembling a smart Lego set. Watching your model improve with each training epoch keeps you hooked. Convolutional neural networks, CNNs, mimic the way your own eyes and brain perceive images, focusing on edges, textures, and shapes like an artist sketching outlines. This analogy helps you grasp why CNNs are unbeatable at image recognition tasks, from spotting tumors to sorting cats. Training deep nets is tricky; they can overfit or get stuck. Aurélien shares clever hacks like dropout, batch normalization, and adaptive learning rates, which act like coaching techniques for your model. These tricks help the model avoid burnout and stay sharp, making the training process smoother and faster. The book doesn't stop at teaching you tools. Aurélien pushes the boundary. How do you scale, optimize, and deploy intelligent systems that actually work under real-world conditions? Imagine combining multiple models like a rock band, each instrument playing differently but harmonizing to produce richer sound. Aurélien explains ensemble methods like random forests and boosting as this musical collaboration, dramatically improving prediction accuracy by aggregating many weaker learners. When your dataset grows beyond your laptop's patience, the book introduces methods to distribute training on clusters or the cloud. It's like going from sprinting solo to joining a relay team, sharing the load to get results faster, crucial for big companies like Google or startups with massive data. The final surprise: reinforcement learning. Here, machines aren't just passive learners; they take actions, learn from rewards or punishments, and improve over time. Picture training a virtual dog with commands and treats, helping it figure out tricks on its own. It's AI with agency, poised to revolutionize robotics and gaming. Remember that laptop screen in Boston with Aurélien's housing price predictor? It wasn't magic, just layers of simple, graspable steps. Hands-on machine learning isn't about drowning in theory, it's about building intuition by doing. So here's your challenge: pick any dataset, spin up Scikit-Learn or TensorFlow, and train your first model today. You'll see once you start, the machine learning world unfolds like a story you get to write. Subscribe for more book summaries like this one.